Hello, welcome to the webinar about future-proofing metal process optimization with ABB Ability Expert Optimizer. My name is Ryan Courts and I'm the Product Marketing Manager for Process Performance at ABB. I'm based in Switzerland and I have a background in applying advanced process control to a number of industries. Expert Optimizer is ABB's advanced process control solution for the metals industry. It forms a key component to our industrial software process performance pillar. Later in the webinar, we have a guest contribution. Prem Prabhakaran, the Digital Transformation Manager at Full Health Infotech, shares his thoughts and experiences in applying digital to industry. And we also look at Bahrain Steel's digital transformation program with ABB, where advanced process control and related technologies are helping improve operations in terms of improving productivity and reducing cost. We are also very interested to understand how you are adopting industrial software and where you see the biggest opportunities for process improvements in your operations. So feel free to drop your thoughts into the chat window anytime during the webinar. So why are we here today? Metals is a harsh environment. How can you improve operations by exposing more information whilst acting on this information in an automatic way? Advanced process control and complementing technologies can play a dominant role in driving your bottom line. For example, reducing fuel gas or maximizing throughput in milling. An autopilot that frees up operators constantly pushing process constraints whilst looking at opportunities to minimize consumables. So at ABB, we contribute to industry's quest for increasing efficiency through our leading technologies. We facilitate a low carbon society. And just to give you a flavor of some interesting recent examples where ABB is helping future-proof plants digitally to help them reach their current goals. So at Heidelberg Materials, Mokra plant in the Czech Republic has chosen ABB for automation and digitalization through ABB's 800XA DC system and Expert Optimizer. At ABB and the mining company LKAB are looking to become the world's first large-scale fossil-free method of steel production. So here the project is set to define fossil-free energy to reduce CO2 emissions by replacing coal with hydrogen in the steel-making process. And at Simindo, energy efficiency and digitalization is core to PT Simindo Gemelang's sustainability strategy. To improve energy efficiency, the company has adopted ABB Ability Expert Optimizer, the advanced process control solution for controlling, stabilizing, and optimizing operations of the mills and kilns at its Bayer integrated plant. So what exactly is advanced process control? I'm sure most people on the call have a fair idea, just so we're all on the same page. Advanced process control is normally referred to as the level 2 application that resides on level 2 and facilitates closed loop optimization of the plant. With minimal operator supervision. So if you think of layer 0 as the devices in the fields and instrumentation and equipment, such as the pumps, the conveyors, valves, drives, etc. And then the level 1 being the plant's control system, PLC, DCS. And then with advanced process control residing on level 2, where the advanced process control is an umbrella term for a number of technologies such as model predictive control, fuzzy logic, where the task of the APC is to automatically understand the current state of the process, how far away the state is from targets, such as what's my current temperature, pressures, etc., and how far away these are from targets, and then facilitating closed loop control to drive the plant closer to these targets in a method that works much more frequently than an operator. So where an operator might make corrective actions every several hours, depending on how attentive they are, the advanced process controller is making these corrective actions every 20, 30, 60 seconds, depending on the unit. So the idea is that with an operator, he or she is less attentive because they have a lot more on their plate. So the average of a particular state, temperature, pressure, etc., would be a comfortable way away from a limit, thereby, on average, not violating these limits frequently. But in doing so, the plant is running further away from an optimum. But the positive for the operator is that it takes less mental energy sustaining it at that point. So with advanced process control, because you're now dealing with the multi-interactions of that particular unit, and it understands it through data-driven models or an expert type system, by making control actions every 20, 30, 60 seconds, it automatically reduces the variability and thereby opens up room for optimization running either closer to a higher upper limit or to a lower limit. So in this example, the plant's economic optimum would be running at this particular variable. Let's say it's an oxygen, closer to a lower limit. Oxygen is an example where you'd normally run at a lower limit because it means you are introducing less air into the system, thereby not cooling it down as much, not needing as much fuel to maintain a specific target temperature, thereby running it in a more efficient state. So in general, advanced process control does not get distracted like human operators. It has small but more frequent changes to the process. It reduces the deviation, which gives room for optimization. It's consistent 24/7, and it reduces the shift-to-shift variation, often seen by having multiple shifts operating a plant. So with Expert Optimizer being a product facilitating advanced process control, I like to see Expert Optimizer as the toolbox where you have the right tool for the right application. So some of the tools available would be the Model Predictive Control Engine, where Model Predictive Control uses dynamic models of your process, which are obtained empirically from your process data. So it's unique to your process, and it uses the models, dynamic models of your process with the current states. So the current states of temperatures, pressures, feeds, densities, etc., with the recent historical states to predict the future based on the model, the future states, and then how far these future states are away from targets or constraints, and then what control actions are required to drive the process closer to these targets, and how long that's going to take, and how aggressively or passively is up to you when defining the controller. Up to you and the ABB engineer. Where fuzzy logic is a rule-based system which mimics the operator reasoning in controlling the process. It's been around for quite a few decades now, so it's not something new, but it's something that is available in the toolbox and fairly robust. There's also the option for inferential modeling platform, which facilitates the creation of soft sensors, which are quite common throughout most industries. An inferential or a soft sensor allows the creation of a model for either inferring states that are less frequently measured, for example, lab sample assays or lab samples in general, where you have a sample taken every few hours, and it would be advantageous for the operators and plant to have an estimate of that particular sample in between. So with the IMP tool, is the ability to create an estimate online for an operator, or either to feed that into the expert optimizer system to then form closed loop control on that particular state. So you are pushing that particular state closer to target more frequently, rather than having to rely on a lab sample coming back every few hours. And then it's normally too late anyway to make corrective action. There's also the ability to integrate with Knowledge Manager, which is facilitating KPI monitoring. So you have a better understanding of how operators are using the expert optimizer system, as well as how is it performing in general. Are we constraining the manipulated variables? Are we often violating control variable limits? And what particular actions are required from engineering or operators to allow the expert optimizer to operate better? There's also the ability with Knowledge Manager and Expert Optimizer to integrate with the plant's LIMS system, so that the lab information is available to Expert Optimizer to make to increase the scope of the application to include particular states in the optimization strategy. Just an example of the inferential modeling platform for the creation of soft sensors. Here we have an NOx estimation where the predicted state is in orange and the actual measurement is in green. So this is just to illustrate that if the if the actual estimate were to also go down due to a faulty reading, you would also have the predicted as a backup to continue control of the plant. So that's another use for the inferential modeling platform, is for also sensor validation. So we are now joined, like I said earlier in the start of the webinar, by Prem Prabhakaran, who is the Digital Transformation Manager at Full Health Infotech, which involves the Bahrain Steel operation in Bahrain. So Bahrain Steel is a mine-to-metal iron ore pelletizer located in the heart of the Arabian Gulf. Its twin plants have combined rated capacity of around 12 million tons of pellets for either direct reduction or blast furnace steel making. So Prem will share his experiences in working on digital transformation projects and how to realize value from digital and the current industry priorities. So thanks, Prem. I'll take that over to you.
So I've been working on digital areas for quite some time. So here I'm mainly focusing to deliver three key messages. First is, what is the benefit of digitalization to the industry or to the company? And then how to realize value. That is one of the major challenge. and the typical priority use cases which we use in the industry, or at least I have tried out. So the first message is being the benefits. So benefits are, it's all around the company's sustainability, the business and process sustainability. So it includes the operational agility, cost saving, and safety. It's a very high level word, but under operational agility, see, every company is in different stages. Some are highly matured, some are in the middle, some are greenfield projects, or just starting stage. So in whichever way it is, we want process efficiency and improving the performance or sustaining the performance. Which if we achieved a magic formula, then we need to sustain, or if we are not reached some area, then we need to improve and reduce the downtime and increase the productivity. All these things comes under operational agility. And under cost saving, I would say there is energy efficiency is a hot topic, which is everybody has to pursue. There is no option left for this. And reducing the wastage. It is not only the wastage of materials. It is probably the people's time, because you will have some key resources available who knows the business, but they will be engaged in so many activities, and they will not be able to contribute better to business. So some kind of automation, some kind of digital enablement will help them to contribute better to the organization. So there is reducing the wastage is a broader topic, and then optimizing the maintenance processes. So optimizing maintenance process, a lot of you don't have to put a lot of IoTs plug in, but maybe with the existing setup itself, it can be optimized with a lot of digital tools or analytics and all those areas. And then safety is a key priority. Safety is a part of culture. So uh, many areas, digital use cases around safety, it takes a lot of time to realize the value. But if you consider it as an enabler, or helping people to improve the process on a longer run, then there are so many use cases around safety which can actually improve the industrial automation, or augmented realities, or lidar systems, or there are so many cases around safety as well. So these areas where digital can benefit the company. And let's discuss about how to realize the value. These are, like, when we talk about digital, it is more of an organized way of executing the projects, not a disparate implementations here and there from the business units. So to achieve these benefits, we need to have a clear strategy roadmap, and then investing in the people. So without these, it is very difficult to realize value, because people will start many POCs, and some implementations here and there. With each technology, we'll try it out, but it may not be sustainable. So the first thing is like top management alignment. So every company has a 1 year goal, 3 year goal, 5 year goal. So what is the business priority we need to understand, and then create a digital strategy around that. It's not that set up a data lake, purchase IoTs. No, it doesn't work that way. So if the company has to achieve this in 1 year, 2 year, 3 year, then to enable that, what is the digital tool which we can implement? So it's always a business enabler, rather than it's no more a support function. It is kind of an upper hand on the business itself. So what is the business strategy and business goal, and to achieve that, what are the tools which we can implement? So that should be the part of a digital strategy. So, and once this strategy is set up, there should be a roadmap. So how this roadmap is made, it's essentially from every department we collect the requirements, and then prepare the use case. So you can prepare the use case based on the current situation and the proposed situation, and then identify how much is the cost involved and what is the potential benefit. It need not be accurate, but it can be a rough estimate. Then you can prioritize this, saying that these are the priorities. it is not only based on the ROI or payback period. It is based on the strategy which we already discussed. Some cases are required for the business. It could help people. It could be safety initiatives. It could improve the customer satisfaction, because once digital came, every manufacturing unit is actually connected with their customer and vendor in a very sophisticated way. So you can actually go into the details and then help the customers, and also have a good quality discussion with the vendors based on the data. So to enable this data driven decision making and discussions, probably digital can give a lot of value addition. So this roadmap is based on the business strategy, and then the payback period of the use cases, and the enablement which can give benefit to business. So once this roadmap is made, then we can start implementing one by one. So it could be, some are, I'll discuss on the process. Yeah, these are some of the processes which is, typical use cases which is implemented in the industry. So it can be in any order. So based on your business, um, the main thing is, the product traceability. We say customer intimacy and customer satisfaction, and also it is not possible to give, a real good customer intimacy or customer interactions if there is no unit identification of each and every product. So it is quite challenging, but at the same time, whichever system you are using, it could be level one, level two systems, or maybe ERP systems like SAP, Oracle. So in whichever system it is, or maybe there is QR code, as I think Tarun has mentioned, mechanisms around OCR, which can connect with engraved batch numbers or QRs and all. So there are systems or tools available at present which can actually perform unit identification. So you can actually switch from a make to stock scenario to make to order scenario, and then for each product category, you should have a visibility and traceability from end to end, so that it could be on QC, it could be on logistics, it could be on sales, and at the end it should be related to costing. So then we will come to know like what is actual product cost for this type of product, and then what is the margin you are getting. So you can also benefit, and you can also interact with customers on a better way. So this unit identification is very much possible with a right involvement of digital. And then another use case which is easy to implement is RPAs. So, as I mentioned before, there are many key business users who are maybe with the industry for some time, or they can actually contribute if they have time. So many companies fail in RPA because they come up with the idea saying that it is going to be automated and your job will be lost. But instead, the idea to pitch in is like, you will get better quality time to, enhance business or contribute to business when you avoid your routine activities. So avoid the routine activities through digital bots, and then enable the user to perform, actually contribute to the business. And then there comes the analytics. Analytics, I don't have to explain much about that, but your key KPIs and real-time traceability, and there are so many things around analytics and um, uh, dashboards which can help every company. Then there is industrial automation. I think Tarun has already mentioned energy optimization, advanced analytics. So once you have the unit identification, which I mentioned, all those things are available. Then only you can do the advanced analytics. Many companies will straight away start with analytics, and they understand that there is no data. But instead, end of the projects, they realize that analytics is not working for us. But it is not the analytics; it is the data availability, or the data, the granular data at a very clean level. If it is not available, then probably advanced analytics will not be successful. So to make any digital project successful, we should have the detailed traceability and clean data. So even if many companies go with data lakes and AWS or Amazon, it is all good, but at the same time, that is not the, as I mentioned before, it is not the strategy or the business priority. There is a requirement to be met, and once you meet that, and once your analytics models are performing, even with the small SQL or your SAP, Oracle, or level 2 data, or even with Excel, if it is working, then you can switch to data warehouse or data lake and all those platforms. I'm not against that, but at the same time, the first priority should be the business value realization. And then predictive maintenance, augmented reality, 3D. 3D is still new to the industry, but at the same time, it is being tried out by many companies. But augmented reality is something which is probably very successfully we have implemented. So it is for the metals industry. It can be tried out because many companies have a lot of key resources who are extremely knowledgeable. So their knowledge can be captured digitally. Currently, what happens is like a person who are involved in the company for a long time or the key processes, once they leave, that knowledge leaves. Even if they have trained people, it is not fully available to the company. But when you use these technologies like AR, you actually take their full video and information, and you connect with your level 2 systems and all, L1, L2 systems, and you capture their knowledge and store it in a digital format. So tomorrow, if there's a maintenance requirement, training requirements, or any process improvement, you can always use that. Thank you.
Thank you, Prem. Your thoughts and experiences there are much appreciated. So to continue with Bahrain Steel, in 2019, Bahrain Steel and its sister companies from the Folath Group engaged in an all-out commitment to a state-of-the-art digitalization transformation program. This focused on expanding on top of the existing base level of control and optimization. So already in place was ABB's control system, which is 800XA. I've highlighted a range of features here, but I'm not going to go through them. As well as the existing knowledge manager, which is continuing to evolve, and the ongoing work in maintaining the system, expanding its functionality, interfacing with the SAP system, centralizing the knowledge manager data in terms of compiling data from both plants into one system, which is obviously very, very powerful. And what the Expert Optimizer also takes into account and exploits is the integration with the LIMS system. So being able to manage, interact, and read information from the lab. And then recently, the addition of Expert Optimizer. So here, Bahrain Steel, we're looking for a level 2 system to facilitate advanced process control, like I mentioned at the start. So here, focusing on a phased approach, first addressing the milling, optimization upstream. So here, stabilization and energy consumption were the main priorities before looking at the downstream opportunities in terms of pyro optimization. So the Expert Optimizer applied to the grinding mills, acting as an autopilot for ongoing optimization. So here it's currently applied to plant 2, where there are 3 grinding mills, which are with a capacity of around 1,000 tons per hour. So here what's interesting is the Expert Optimizer is constantly looking and observing the states of the mill drive loads, the outlet temperature, the pressures in the mills, the inlet temperatures, the elevator load, and the returns. And then based on these current observations of states, understanding how far these are from targets and limits, making control actions to constantly push this particular process closer to these desired targets from operations. Looking to take control of the separator speeds, the gas valves, and the air dampeners in the process. And so by doing this, the ongoing target of the Expert Optimizer application is to improve load stabilization, improve the stabilization of the outlet temperatures of the mills, improving the dust bag filter efficiency, and by overall stabilizing the circuit, reducing specific energy consumption of both electricity and gas. One other, you could say, non-tangible in terms of metrics benefit would be the significant reduction in operator workload on this particular unit of 3 mills. So this was observed by plant personnel, which allows those operators to focus on different parts of the process. So now that these 3 mills are in a autopilot mode for the majority of the time, they have more capacity to take control actions over different units of the plant that don't currently have Expert Optimizer. So this final slide. Firstly, big thank you to Prem and Bahrain Steel for providing their content and sharing those insights. So why future-proof with ABB industrial software? I think a biggie, critical, and one that is, I believe, extremely important for any longevity of any digital transformation program, support and training. So experts support both remote and on-site for sustaining the benefits of the solution. So hands-on training for both operators and engineers on how to use the software and even develop their own solutions. So standard and advanced courses are available, as well as the model builder if a more hands-on ownership type solution would be best for your particular plant and personnel. So it's not just ABB doing the modeling and commissioning. There's also the ability for you to take over that role if you so wish. Expert Optimizer is a proven solution. So for over 25 years, it's been proven to increase profitability, productivity through increasing throughput, reducing costs, increasing yield, with over hundreds of installations worldwide, as well as ongoing development to enhance the solution, utilizing both partnerships as well as internal R&D. So thank you for attending, and if you haven't done so already, it would be great to hear from you where you see or believe quick wins are in your processing plant for increasing profitability. And we will now open up the webinar for questions. So please pop those in the chat window, and I'll look forward to answering those questions. Thank you very much.